electrocardiogram objectives. Objective number 2 is to understand and discuss the deflections on the ECG tracings. So I'm going to do a quick video that explains basically what these tracings mean. First, I'm going to go through the whole thing, starting at the beginning. Starting out, we have the TP region here, which is then going to go into the P wave, followed by the PR segment, which is then followed by the Qrs complex. So we've got the Q wave, the R wave, and the S wave. Then we hit the J point right here. Then we go into the ST segment, followed by the T wave. Then we have the U wave, and go back in the TP. So it's pretty nice because if you start right here, it's actually alphabetical: P, Q, R, S, T, U. U's don't usually show up, and then it goes back, of course, into from T back to P again, B. So anyway, the only thing that's a little confusing is this segment goes to PR segment, and if you just think about it, it kind of hits the middle of this. I don't know really why they call it P. It seems like it should be called the PQ segment, but whatever. Maybe sometimes it's because this Q isn't there. I don't know. Okay, so now we're going to talk about what these different things represent. So the TP segment here, of course, is the period of rest. This is when things are relaxed. So that means that there is essentially, we're at baseline, it's also called the isoelectric line. There is no electrical activity. The P wave is going to represent the depolarization of the atria. And sometimes that can be kind of looked at as depolarization of the SA node. So if you remember over here, here are the atria up at the top. So the atria essentially get filled in passively from the left atrium from the lungs, the right atrium from the body, the superior vena cava and inferior vena cava. And then when these contract, they're going to squeeze the blood. So now they're depolarizing, which means they're going to start contracting. They're going to squeeze the blood into the ventricles. So this is where that depolarizes. And it's this entire P wave is only going to last, maybe 0.1 seconds or even less. 0.1 seconds shows up on those little EKG reading boxes as like 2.5 small boxes. As if you remember, a huge big box or 5 small boxes is going to be 0.2. So 0.1 is like half of that. And so this is where the atria depolarizes, and you wonder, okay, so where does the atria repolarize in here? Where's that been picked up? Well, it's hidden. It's hidden in here. You can't see it. It's such a small electrical activity compared to the massive ventricular depolarization that it's kind of like it goes on in here, but you can't really see it because this is more dominant. It'd be like whispering when someone else is shouting. Okay, after the P wave, the P wave, which is the atrial depolarization. Oh, by the way, right here, beginning is where the SA node would depolarize. Let me go up here to the anatomy. If you remember, we have the SA node, which gets, they can receive parasympathetic stimulation from the vagus. That slows down the signal. So the SA node is conducted through the internodal pathways, the fast one, internodal pathway, and the slow one at the bottom. The fast hits first, and it usually stops the signal here. Those reach the AV node, which then depolarizes and sends a signal through the bundle of His, and then that's going to send from the bundle of His electrical signals through the left bundle branch and the right bundle branch. The right bundle branch is going to go down here and fire on the Purkinje fibers, and the left bundle branch is pretty short because it breaks up into the left posterior fascicle and the left anterior fascicle. And that's where you'd see like bundle branch blocks and stuff is in here, in the little branches. So now we're going to go on to kind of covering what happens here. There's this little, it kind of seems kind of confusing because there's a P wave, there's a PR interval, and there's a PR segment, okay? So if you think segment is small, okay? It's the small one. And an interval is enormous, okay? So here's the enormous interval and the small segment, okay? So, and then you've got, of course, the P wave is the only thing that looks like a wave. None of these other ones look like a wave, and that might help you to kind of get that straight. So during the PR segment, there's actually a lot of things that are occurring here, because remember that ultimately the ventricular depolarization is the goal here, but it has to run through the electrical conduction system of the heart. And so following, we had the SA node that fired, then it goes into the atria firing. Let's go down here to the, all in this piece, the PR segment is going to be the AV node firing, the bundle of His firing, the left bundle branch, right bundle branch firing, and the Purkinje fibers firing. And so this PR segment basically traces everything starting at the end of the atrial depolarization all the way to reaching the Purkinje fibers depolarizing. Following this, we go into the Q, R, and S complex, which is composed of 3 waves: Q wave, R wave, and S wave. And this is really big because it represents the biggest electrical event in the heart, which is the ventricular depolarization. It also is very quickly. It occurs very quickly, so it's going to be less than 0.12 seconds. Again, that's just maybe, something like 3 boxes. It's not very big. So now we're going to go to basically showing you that there's lots of different ways that this can present. The QRS complex is not always very pretty. Sometimes it's kind of ugly. Sometimes it might be lacking entirely a Q wave. And if it's lacking the Q wave, you still call it the QRS complex, but if you're referring to being more specific about it, you might just call it the RS wave, because it just has R and S. There's no Q. You can see that. In other instances, when you're looking at this, you might say, okay, so what if it doesn't have an S wave? What if it just has the Q wave? Well, that you can record that as well and label that. Or what if it doesn't have? What if it has this huge S wave, or doesn't have the Q wave, but you could just call it, again, the RS wave, but maybe a lowercase r is the way he drew it on the video. Again, also in this one, this is odd. This is actually lacking a Q and it's lacking an S wave. And for some reason they just call it an RS wave. This is what he called it in the video, even though it's lacking both of the other waves. Just looks like a big R, but they call it an RS wave. And then over here in this instance, you can see this. Yeah, you can barely. Sometimes it looks like it's missing the R wave, and is just like one big down negative reading. And in that case, yeah, it's missing the R, so they'd call it the QS wave. And then in other instances, sometimes when you have a left bundle branch block or a bundle branch block, what you're going to see essentially is, because one of these branches is blocked, it would fire. I think it would have to be a left bundle branch block, because this one usually goes faster. So in this case, the right bundle branch is going to actually depolarize or fire on the right ventricle first, and then there'll be a little bit of a delay, and then the left ventricle will fire. And so what you see here is that you essentially have to transpose 2 separate ventricular depolarization events on top of each other, and you get this kind of telltale sign that they call the bunny ears here, where it's like 2 little spikes. And what this really is electrical representation on an EKG of 2 ventricular events occurring in different time periods, shortly one after the other one, because this was blocked. The signal isn't actually completely blocked. Really what it has to do is it just has to go around through the myocardium, and then it's going to hit on this other ventricle. So that still fires, it just takes longer, because that's a less direct signal than going through the left bundle branch and into the left posterior fascicle and the left anterior fascicle. So in this case, what you'd have is you'd have an R, and then the second bump you'd call the R, or the wave rather, you'd call the R prime. So if you were to label this, you'd call it an R prime S wave. Going back down here, sometimes, again, this can look all kinds of different ways, and it's all considered QRS complex. Sometimes there'll be a little R wave, because remember the R is going to be the first positive deflection. There's actually a definition of this. You don't say, well, the first event is the Q. No, the first negative wave is the Q. If it never goes negative, then there is no Q. The first positive wave is considered the R. So in this case, it never actually hit the R segment. What it did is it went straight into the, it never hit the Q segment, went straight into the R, and then it has this large S, which is a negative. You call it S because it's the one that follows the R, that's negative, so this would be S, but then it has a second R, which is unusual. Okay, you wouldn't call that the T wave because it's totally the wrong place. You'd call that also an R prime. It's the second R. Okay, so you call it R, S, R prime wave. So there's lots of different ways of labeling that, but you got to be very careful in understanding that the Q wave is going to be the first negative electrical reading following the PR segment, and that the R is going to be the first positive, and then R prime would be the second positive, and S would be the first negative following an R. And if you remember those rules, then you get it right when you're going to name it. Now we're going to move on to the J point. The J point is going to be, it represents the junction point. It's a junction going from the Qrs complex into the ST segment. And the J point is going to be on baseline. Sometimes it can be 1 millimeter, up above or below. It's still considered the J point. And following the ST segment, we go into the T wave. Oh, I should probably say too, this ST segment represents the time between ventricular depolarization and ventricular repolarization. So there's a little bit of a period between there before it starts to repolarize again, where the muscles are in a depolarized state, and then they're going to relax, and then they're going to start to repolarize again. So that's what this ST segment represents. Then we go into the ventricular repolarization. So now they fired, and now they need to repolarize again. So this repolarization, it needs to look asymmetric. In other words, it has to have a long upward slope at the beginning, and then a more quick drop at the end. This is again called the T wave, and following the T wave, sometimes, not very often, you're going to have a U wave, and that's not really clinically significant. They have some theories about what it is, but nothing's very conclusive. And that is going to be the entirety of the second objective, which is to understand and discuss the deflections on ECG tracings.